It is now time to see how Stuxnet propagates either within the network or through removable drives. So Stuxnet, as I just said, has two ways of propagating. One would be network and one would be removable drives. Network, it has 5 ways, and we'll see each one of them individually. One would be that peer-to-peer communication, the other one infecting WinCC machines, that is Siemens software. It propagates to network shares. That's not a vulnerability, but if it finds something that's open as a network share, it will copy itself there. And another zero-day vulnerability will be the print spooler one, MS10 061, or it could have been another vulnerability, the MS08 067. That's the Windows Server Service, the SMB one. So 5 ways to propagate through the network and 2 ways to propagate through removable drives. That will be the LNK vulnerability we'll see, and the autorun.inf, the ability to auto-execute an executable from the drive when the drive is inserted. But let's start going through the 5 network propagation methods. First will be peer-to-peer communication. This works by installing an RPC server and client. Again, remember that Stuxnet, after infection, runs as administrator, so it can install software as well without the user realizing. So when Stuxnet is infecting the machine, Stuxnet would also install an RPC server and a client. So Stuxnet infected machines can talk to each other, and this is how Stuxnet had these linear branches, how it was propagating from machine to machine sequentially, and it managed to update itself. So when Stuxnet infects a computer, it will start the RPC server and listen to connection. And then if some connection is established, there is a version number check. So you see here, there's a client server. You call the RPC 0, you get the versioning, you send the install version number, and you find what is the latest one. If the server has a latest Stuxnet, the versioning is installed in this configuration data block, then you would receive the Stuxnet version that is the latest one, and you would update yourself in this case. So install the latest Stuxnet version. And the RPC, so the RPC was great for within the LAN. Again, Stuxnet didn't try to do things over the internet, but it was effective through the LAN. So once you have infiltrated the network, then this is the way it would propagate, and would actually maintain the connection to propagate through the network and to jump from the different layers, from the business layer, enterprise, all the way down to the operation layer. Second method of network propagation would be infection of computers that would execute the WinCC Siemens software. So when Stuxnet would find that system by either looking at the processes running or by checking the registry, it would connect to the database server using a password that is hard-coded within the software. That the database actually would be it's a database server, so it's an IP listening to requests to that database. So you can download, for example, projects from another location. And then once Stuxnet would find those devices, then it would perform 2 actions. I would connect to the database by that hard-coded password, so it didn't need to know credentials to connect to the database. And after it connected, it would send malicious SQL code, and that would transfer a Stuxnet version to it. This, you would create a table, and then you create an entry in the table. That entry actually will be Stuxnet itself. So you now have Stuxnet copied to the other side, and you can execute SQL commands that are system commands and would execute actually the database content you just sent over. So that's a way to make sure to actually have Stuxnet executed on the other device. The second thing Stuxnet would do is that the software would have different views, and different views will give you parts of the visibility to parts of the process in different ways for you to understand different aspects of your ICS. So Stuxnet would modify a very specific view and add code to it to be executed every time that view was accessed. So when you have your HMI and you bring up that specific view, then Stuxnet will install itself again in case it was removed or in case it wasn't running. So let's now see each one of these methods in detail. The first one would be through SQL injection, and in that way, Stuxnet is making a query to the SQL, to the database using that hard-coded password to connect to it, and then that it will send an SQL statement that will create a table and insert a binary value to the table. So you see you have this create table command, and after you create a table, you insert into the table specific values. And the values actually added is Stuxnet itself, is the DLL of Stuxnet itself. And then if that's successful, then SQL is using this automation store procedures to write itself to the disk, from the database to the disk, and then it will be added, the file is added as a store procedure and is being executed. So Stuxnet would execute itself. It would copy it as a database entry, store from the database to the disk, and execute that file from the disk. That's actually inexecutable now. After this happens, then Stuxnet cleans up and the main DLL is deleted, and Stuxnet would also save a CAB file from another resource it has. That's important for one of the later propagation methods. The second thing is the modified view. We just said there's this specific name of the view that you can read on the slide. So whenever this view would be brought up, then Stuxnet would reload itself. And to do that, it would modify that view, and that view would have a series of commands it would bring, and it would append to the end of that text field SQL code to be executed. And that will be from what we discussed before, this saved CAB file, and using the command shell, it would execute Stuxnet from that file. And these are the commands used to do that, to the final execution of Stuxnet. So you see here you have an example of the view. So whenever you would bring up that view, then Stuxnet would have added some specific commands whenever the view is brought it to execute itself from that saved file. Let's move to the third way Stuxnet would propagate. Stuxnet would propagate through network shares, and this is not a vulnerability as such. This would fall more under this configuration, where you have available network shares that everybody can write to. So Stuxnet would spread to whatever was accessible and would copy itself there, and it would enumerate all user accounts and try all resources to copy itself and execute on the remote share. Specifically, it will determine whether the admin $sign share will be accessible, and then build the executable using one of the resources in the DLL, and after enumerating, it would copy the executable it just dropped to a random file name in that form that looks something that like the fragmentation process that doesn't look very suspicious, and it would schedule a network job to make sure that the file will be executed 2 minutes after infection. So it would send file to any available network shares, and it will schedule a network job to execute that file, and that file will be executed locally and infect that machine as well. Fourth propagation method was a zero-day vulnerability on the print spooler service of Windows. And the way to do that, it's tied to how Windows was actually printing files. So what Stuxnet did, it was impersonating the printer spooler service to create a file. When you want to print something, you create a file actually, and then you tell the printer, go and print that file. And you want, this is a printer shared across the network, and you want to send a print job to another IP in your system. So you send that file over, and then you ask the printer to print that file. But of course, since you can send a file, of course, you probably understand by now that Stuxnet would send itself, and we should find a way to execute after it's being copied to the other side. And the fact that you can send to any directory, you can send it to system32 of system root, and then you have now the ability, since you can specify any file name or any path, you have full control of the content, and then you write to a directory that's special directory, this one, and this special directory is used by the Windows management instrumentation to deploy applications. So essentially, you're sending a file to be printed, but that's Stuxnet, and since you can put it anywhere, you put it in a directory that will execute files. This directory is being read periodically by WMI, and it executes files it finds there. So you just copy yourself there, and then WMI would execute that file by executing Stuxnet again. It has a deadline. It was a time bomb as well. It would stop at June 1st, 2011. If the date was passed, it wouldn't be able to try to do that because it would have been detected. The final network propagation method would be through the Samba service, the Windows Server Service, and this one was an older vulnerability. That the 08 here means that it was first discovered in 2008. So in case the system wasn't patched, that vulnerability could have been exploited. So this is a buffer overflow vulnerability that you can exploit by connecting over SMB and sending a malformed path that will allow remote code execution. And the vulnerability is caused by this function, this netpr path canonicalize function, that is not checking the bounds of some of the fields you're sending. In this case would be one of the directory ones, this RPC path buffer. It is not bounds checked, so you can send more data that the application is expecting. You overwrite the buffer, you overflow the buffer, and you overwrite the return address to point to locations that you have your own code, so you can have your own remote execution. That's a regular buffer overflow attack, very, very standard one. Also, there's some checks Stuxnet does, verifies the date. It also checks for antivirus because that was a known vulnerability exploited by other malware. It was checking whether the antivirus products were dated before some day or older ones. And if they were, it wouldn't try to exploit that because it knew that newer antiviruses knew of the vulnerability and they were protecting against that. It was also checking whether patches were applied, whether those two files had timestamps before the patch day that was fixing that vulnerability. And we discussed that it's a good point to bring up that this is why patching is essential, right? This is why it's important to make sure that you have up-to-date patches, versions of your antiviruses to ensure that these vulnerabilities of the past cannot be used to attack your system. So this concludes the network side. Let's move to how Stuxnet propagated through removable drives. So there were two ways. One would be a vulnerability one, this link vulnerability, and these link files are the shortcut files we see and use in Windows. So this way that Stuxnet, that was the CV 2010, and this copying, removable drive copying will be implemented by exports 1, 19, and 32. And they all implement, we'll see what they do, they implement different things. And we discussed in previous videos, Stuxnet had rate limiting options where, for example, if the removable drive has infected 3 computers, then it will just delete itself to make sure it doesn't spread uncontrollably. More details about the vulnerability depends on the export it was used to be called. If it was export 1 or 32, then Stuxnet will verify if it's running within a specific process, services.exe, and also determine a version of Windows, and then it will create a new hidden window waiting for a USB drive to be inserted. So think of Stuxnet waiting in the background for USB, and once that was done, it would just copy the files to that drive. It will also do a timestamp check, and then it will delete files that were previously on that drive before proceeding. And you can see on the bottom the condition for ejections, that the drive wasn't infected, that the flag to infect drives was on. Infection is less than 21 days old. The drive has some free space, and the drive has at least 3 files, so it doesn't look suspicious. And it would create the files we saw before, the 4 LNK files that had specially crafted code in them to exploit that vulnerability, this one, and the 2 files that would essentially be Stuxnet itself. So this is the Stuxnet main DLL, 500 kilobytes, and the other one that would exploit the vulnerability of the LNK to load Stuxnet. Now let's see what this vulnerability is about. When you open a directory in Windows, you may have some icons that are shortcuts, some files actually that are shortcuts, and these files would be LNK files. They would point to something else. And when these files are created, they also have an icon. Here we don't see an icon in this case, so when an icon is not found, then a default icon is being displayed. But the icon would come from either the file itself or from another DLL file. So this is what this vulnerability was exploiting. So these LNK files that were in the directory that Stuxnet was installed in the USB drive would have this exploit that it would execute this file just when simply viewing the folder. And this happened because when Windows is trying to present the contents of the folder, like here, it tries to also load the icons automatically. But doing so, it doesn't do any checks. It doesn't see whether the icon is trying to load is something that's not an icon. And that's exactly what Stuxnet exploited, and this vulnerability is exploiting. Because Windows doesn't check, instead of an icon, there was code that would load Stuxnet. Not the final rootkit that we saw before, the more robust one, but it was a lightweight version of it that would attempt to hide the files on the removable drive. Because rootkit functionality has not been installed yet. So to summarize, once the drive would be inserted, then when you would try to view the contents of the USB drive, then this LNK vulnerability would be used to load this file, 4141, and then this file would load Stuxnet, and Stuxnet would, before loading, it would create this lightweight rootkit that would look for special load library calls, would be in this case again, show the contents of a directory, and make sure that those files would be hidden from the user before they are seen. So the moment you try to view the folders, Stuxnet would load, hide the files, and then present the rest. The second way Stuxnet was propagating through the removable drives would be exploitation of the autorun.inf file that would indicate to Windows which file to execute when the USB drive or the removable drive is inserted. So this is autorun.inf is a file that is placed on the removable drive and will automatically execute a file, and the idea is that it increases usability. You don't have to go to, you insert the CD-ROM, you don't have to open the browser and go to install.exe to start the installation of the software that you want. Autorun.inf will do it for you. The issue is that this autorun.inf parser, it's pretty forgiving. So when you see on the right side, the autorun.inf footer actually has a lot of information before this autorun tag appears. So the autorun.inf parser will just ignore everything until it finds that tag. And once it finds a tag, it will go and execute the file that you have pointed out for execution. However, what Stuxnet did would be that before the autorun tag here, it would place itself in the beginning of the autorun.inf. So by telling the Windows operating system to run itself, it would go to the beginning of the file and execute Stuxnet. So it would load Stuxnet this way. So again, Stuxnet would have a special, the USB drive will have a special autorun.inf that will be Stuxnet itself, and at the end will have this autorun tag that would ask it to execute itself, the same file, the autorun.inf. So when this happened, Stuxnet would be loaded and would be executed. So you see the beginning, this is a regular executable, and at the end, the footer of the file would be this autorun.inf that would tell Windows just the command you need to run would be autorun.inf that would go to the beginning of the file and start executing this executable. Stuxnet would do another thing as well. You see on here the second, so the first command is what executable would be executed when the drive is inserted. And the second one would add some option in one of the context context menus that Windows uses when, you, for example, you right-click. So this second thing would be used to enhance the chance of execution in case, for example, autorun would be disabled, that Stuxnet wouldn't be executed. Instead, what Stuxnet would do would add the command here, looks like an open command. So there are two open strings when you right-click on the Stuxnet infected drive. The second one would actually execute Stuxnet. So this increases the chances of Stuxnet being executed in the host computer for the computer to be infected.